Graphing quadratics, okay? We graphed them. We looked at all their key features. We used a table to record our 4 key points, mostly the vertex, the y-intercept, and most of the time it was 2 x-intercepts. Sometimes there was only 1 x-intercept because it was the same as the vertex, right? That was a special case. Our 5th point that we could plot was the mirror image of the y-intercept. So we add that sometimes to help make our U shape nice and symmetric. All of the key features are the exact same. It just depends on what kind of form you're given. Each form of the quadratic gives you different information. Vertex form obviously gives you vertex, right? Standard form, this is when you got your A's, B's, and C's. Okay. We got to pull different things from there, right? We could pull the C. What did that C value give you? I know, it's been a couple of days. It was the y-intercept. Our C value gave you the y-intercept. Yeah. We could use opposite B over 2A to find the x axis of symmetry, which is the x coordinate of our vertex. And for all of these, you can always plug in x to find y. Okay. The intercept form, which we also called factored form, gave us our factors, which then led to our x-intercepts. Okay, so for this first example, we have vertex form, we have standard form. It wants us to first rewrite it into factored form. Okay, so it wants it to look like this. So what we're gonna X box with this one. What multiplies to give us -5, but also adds to give me a +4? What is some kind of a 5, some kind of a 1?
-1.
There you go. Yeah. So make sure it makes sense. 5 times -1, that's -5, and 5 minus 1, that is my 4. So my factors are x plus 5 and x minus 1. Okay. Oops, sorry. Go back. Thank you. All right, so now we have all 3 forms of the equation. Each piece gives us something different. Okay. Which one of these can I find the vertex from? Vertex form. Okay. So looking at my vertex form, x plus 2 squared minus 9, what is our vertex going to be? Okay. So remember, this is x minus h. That should be an h. X minus h squared, and that's plus k. Our vertex is hk. Okay, so if it's x plus 2, what is your h value? Almost. -2. See how my original form is x minus h? So if I have +2, that means h was -2. We talked about when we pull things out of our parentheses, their signs always change. And what's our k value going to be? -9. Good. So we didn't pull the 9 out of parentheses, so we're not going to mess with it. It's fine. All right, where can I find my y-intercept? My c value, good, in my standard form. So what's our y-intercept going to be? I'm just going to write -5. There you go, 0, -5. Where are we going to find our x-intercepts? Under factored form. Yeah, so I have my factors. So how do I get my x-intercepts from there? Okay, so what are they going to be? It becomes -5 and +1. So to remind us why that happens, because we take each factor and we made it equal to 0. Because an x-intercept is when x is by itself. So that's why we have -5. And then over here, if I made x minus 1 equals 0 and added the 1 over, we get positive 1. So x-intercepts become negative 5 and positive 1. Yes. You just got here. All right, any questions so far? All right. Are we starting to remember? Yes. Slowly coming back? Okay, good. All right, axis of symmetry. That is the line that cuts our parabola in half. Okay? Is it going to be? No, it's going to be the -2. And is that the x or the y? That is the x. Okay? If I didn't have the vertex to go off of, if I only had standard form, remember we can use opposite b over 2a. So here b is 4, so opposite of that would be -4 over 2 times 1. So -4 over 2. That's also another way where we can get x equals -2. Okay, so that is the line that cuts it in half. All right, do we have a minimum or do we have a maximum with this parabola? Let's think about it. First, let's think, does it open up or does it open down? What do we look at to answer that question? We look at our A, and these all have an A. It's right here, it's right here, it's right here. So they all have an A value of +1, so it's going to open up. It's going to look like this. So the turning point, is that going to be a maximum or a minimum? It's going to be the minimum. It's the lowest point. So this has a minimum. Minimum. There we go. And what is that minimum value? What is the lowest this goes? Yeah, this is -2, -9, right? So our lowest value is going to be the -9. Okay. I'm going to graph it. Is that okay with y'all? I'm going to graph it. Okay. What was our vertex? All right, I'm going to do that one first. So over 2 and then down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Here's our vertex. What was our y-intercept? -5. Okay. 1, 2, 3, 4. There's -5 on my y. So 0, -5. My mirror image, by the way, so see how it's 2 off to the side? I'm going to go 2 to the other way. 1, 2. That's the mirror image. So that's -4, -5. Again, that's not needed. It's just nice because it helps get your shape nice and symmetric. Yeah. So bonus point here is the mirror image of our y-intercept. I'm going to just call it mirror. All right, and then my last 2 key points are my x-intercepts. What were those? Oop, -5 and +1. Now question, if I did not change my signs, let's say we used -1 and +5, see how that doesn't make sense? When you start to plot them, those wouldn't make sense. You'd be like, oh, I forgot to change the signs, okay? So that's a good way to catch yourself to make sure you did things the right way. So they need to be at +1 and -5. 1, 2, 3, 4, 5. Looking at that, now we're symmetric. That makes sense. Okay. I'm going to draw this guy. And there's our beautiful parabola. Yeah. I think is going to help us answer these last little questions. Which one do you want to do first? End behavior? Okay. Where are both of my ends going? So as we go left and as we go right, so as we go to the negatives and positives of my x's, What are the y's doing on both sides? They go positive, yeah. Good, they're both going up. All right, what do y'all want to do next? All right, increase and decrease. Let's do it. So remember, this guy is cutting us in half, right? And this is at -2. So my first half between -infinity and -2, what is little Olivia doing? She's going down. Good, that's my decreasing interval. From -infinity to -2, we are decreasing as we walk along. And then we hit -2 and we start climbing up. So from -2 to positive infinity, we are increasing our y values. So between these x's, my y's are going down. Between these x's, my y's are going up. All right. What's our domain? All together now. Yeah, good, always. All real numbers. Some of you are doing like the double-lined R. That means the same thing. However you want to write it. Almost. All of my y's. It is y at -9 because that's based off of my vertex. They're all greater than. Good. We're opening up, so we're getting bigger. Because that's my minimum point, right? That's the lowest it's going to go. Everything else has to be bigger than that. All right. Is it all coming back to you? Yeah? Good. All right, so our quadratic function, we have our B question now. All they gave me was vertex form, okay? I can find everything else, okay? I can rewrite it. I can do all the stuff. To write it into standard form, we're going to actually simplify our equation. So we're going to take 3x minus 6 squared minus 3, and we're going to simplify to where we get just the ax squared plus bx plus c. Okay. We should do parentheses first, yes? So x minus 6 times x minus 6. That's what it means to be squared, right? To multiply to itself. So there's my exponent. My dear Aunt Sally. So my dear, we need to multiply or divide. We got some multiplying going on, okay? And you have choices. Do you want to distribute the 3 to the x minus 6, or do you want to FOIL x minus 6 and x minus 6? Just distribute the 3? Okay, when you do this, it only goes to this first little bit. So 3x, and that becomes minus 18. And we're still looking at the FOIL. Now we're foiling those two together. Let me zoom in for y'all. There we go. So first, outer, inner, last. 3x times x. There you go. 3x times negative 6.
Oh, negative 18.
Mm-hmm. Negative 18 times x. Negative 18x. Negative 18 times negative 18 times negative 6 gives me positive what? 18 times 6, yeah. 108. Did you get the same thing, Jane?
108.
Okay. Sweet. And don't forget, we still got this minus 3 over here. And you might see why I left that, whole combining like terms worksheet for you, because that's what we're going to have to do now. Combine like terms. Here we go. So we only have one piece with an x squared, right? So 3x squared, there it is. Just an x, just an x. So what's negative 18 minus 18?
I think it's like a negative. No,
Almost.
there
There it is. Good. And then here's a constant of 108 minus 3, so that's going to be 105. This is our standard form. Okay. Notice my A value in the beginning was a 3, right? This guy right here. Look at that. My A value is still a 3. Okay. So for my intercept form or my factored form, okay, now we need to factor this to get our x-intercepts. Do you think we have a greatest common factor? Yeah, it's your A value. What's your A value? 3. Divide this whole thing by 3. We get x squared. We get negative 12x. And someone's going to have to help me. What's 105 divided by 3? 35. And again, recognizing that these all had a 3 out front is what helped me recognize that I'm going to have to pull a 3 out on my factored form. Okay, Xbox time. What multiplies to give me 35, but also adds to give me negative 12? All right, what kind of a 7 and what kind of a 5? Beautiful. So we have 3 times x minus 7 and x minus 5. And there is my factored form. Still with an A value of 3. All of my A's match. So a little bit more work to do up front, but now we're going to be able to easily find all my key features. If you want to. Y'all want to do x-intercept first? Sounds great. What are they? There you go. Positive 7 and positive 5. What else? Nope. What's my y-intercept? What is it? Nope. My y-intercept. Okay, hold on. Go back. Go back to the beginning. Go back over here. Where did we get our y-intercept last time? It was our c value, right? So.
Oh, so it's 105.
Yep. That 3 on the outside is really stretching this parabola really tall. So it's going to go way up to 105. What's our vertex going to be?
3.
Remember, H.
Oh, negative 6.
I agree with this. 6 is in parentheses, so it needs to become positive. There we go. Here, think of this as opposite H. Maybe that'll help. Think of what's in your parentheses as opposite H. So if you have negative 6 in there, your H is really positive 6. Okay? Opposite H is what's in your parentheses. All right. Sure. What is it? There you go. Axis of symmetry is the x value. So to answer my next question, are we opening up or are we opening down? We are opening up. My A is a positive, right? So we're opening up. So my vertex, is that going to be a minimum or a maximum? It's going to be a minimum. It's the lowest point. Minimum. And what is that minimum y value? Where did 7 come from? Lovelies. Yeah, negative 3. The vertex is the turning point. That's going to be your minimum or your maximum. So the lowest we're going to go is where y is negative 3. We're not going to go any lower. which helps you with your range. Let's do that real fast. We're talking about it. So if -3 is as low as my y's are going to go, what's my range going to be? All my other y's. There you go. Yeah. Good. Domain altogether? Yes. Or all numbers. Okay. What do y'all want to do next? In behavior? Okay. So if we're opening up, my left side and my right side are both going where? Up to positive infinity. Yep. For my increase, decrease, I always graph it first. I have to see it. Okay. So my key points, just read. We have 6 and -3. 1, 2, 3, 4, 5, 6. 1, 2, 3. We have x-intercepts at 7 and at 5. This is 6. There's 5. There's 7. Our y-intercept, we're not going to be able to plot, are we? But I'm still going to put it in my list. 0 and 105. It's going to be way up there. Can't really plot that. Okay. You can, but honestly, because the other numbers are just so small, it's okay. You can leave it like that. So as long as you include it in your table, does that make sense? I know you know what it should be, but obviously it's not going to fit in my graph. Okay. I'll make sure, like your quiz though, I'll make sure it all fits. I will double check it today. Because I know that makes y'all worried. There you go. All right, so now I can do my increasing and decreasing intervals. This is where we're spinning. That's a y value, that's an x value of 6, right? So as I walk in from -infinity up to where I walk to a value of x value of 6, are we increasing or are we decreasing? We are falling down first. So we are decreasing between -infinity and +6. And I keep walking, I'm going to go up. So between the x values of 6 and infinity, my y values are increasing in value as we walk up. Okay. So that 3 on the outside, see how it really stretched it compared to the one we just did before? That's what those values do. If it was like 1/2, it would make it wider. All right. Ready for the last one? Okay. Here we go. So our last one, they gave me vertex form and they gave me intercept form. We have to create standard form. Good. Remember, this is the same thing as factored form. If you want to change that, factored form. Okay. All right, so we're going to have to simplify something, right? We learned going from vertex to standard, there was some work going on, right? If I look at intercept form, that looks nice. So here, pick one. It doesn't matter which one you simplify, they're going to give you the same thing. I'm going to go ahead, I'm going to pick factored form. And I'm just going to distribute that -x back through. So -x times x minus 4. We're just going to distribute that guy back in. -x squared, yep. Almost. It'll end up being positive. So I don't have a c value. What's technically there? A 0, yeah. So I'm going to write this as -1x squared plus 4x plus 0, just so I can see my A, B, and my C a little bit more clearly. Do they all have the same A value? They better. What's my A value? -1? Look, -1, -1, -1. They all have an A value of -1. Okay, yeah, so this one's opening down this time. Good, so we know they're all opening down. It's going to be what? Yeah, so we're going to have a maximum this time. Good. All right, what key feature would you like to fill in first? Vertex? All right, what is my vertex? There you go. Oops, that's not going to work. Let's try that again, shall we? There we go. 2 and +4. Remember, this is opposite H, and this is K. So we took the 2 out, made it opposite, so +2. Good. Yep, what's our y-intercept going to be? 0. And how do we know this? Because it's what? Where did you find that? The C. Yeah, in standard form, it was our C value. So our y-intercept is going to be 0, 0. Ooh, what special point is that? The origin. So we know it's going to cross through right there. Isn't that nice? All right, my x-intercepts. Okay, a little bit different than what we're used to, but we're still going to find it the same way. I'm going to do orange. Okay, I have 2 factors. I have -x, and I have x minus 4. Okay, we're still going to make both of them equal to 0 to find my x-intercepts. So my first one, -x equals 0, that negative's in my way. How do I get rid of a negative? No, remember, technically that's a -1. Divide by -1, and we get x equals 0. All right, so that's one of them. And my other one is going to be +4. Okay. I'm going to go ahead and plot those. Is that okay? Okay. 0, 0, and 4, 0. So right there, 1, 2, 3, 4. So what did we notice happen in here? What's special for this guy? Yeah, and it being both of them, which is fine. Happens. When you cross through the origin, it's a special place. We also had my vertex already. What was that? 2, 4? Thank you. Vertex. All right, so 1, 2, and then up 1, 2, 3, 4. So does it make sense? Is my parabola going to open down? Yeah, see how the middle guy is above the x-intercepts? So we got to go down to go through them. Yeah. Let's go ahead and sketch it like this. And if you want to put more points, you can always plug points into one of your equations if you want to. Not necessary, but you can. Y'all did evaluating, I believe, on Friday. Yesterday you had, no, Thursday was combined like terms. I think Friday was evaluating and yesterday was your law of exponents. So Friday stuff kind of helps you plugging things in. Okay, let's finish this problem. What is our axis of symmetry going to be? X equals 2. Good. That is the line that is cutting this parabola in half. All right, we already established we have a maximum. What is that maximum value? Our y is good. The highest we go is where y is 4. What do you want to do next? Increase and decrease? Okay. All right, so I have my beginning, I have my end. That 2 was cutting it in half. So as we walk across the x values of negative infinity and 2, what are my y values doing? Did you say going up? I can translate your yawn. Yes, they are going up. Good. So that is an interval of increase between negative infinity and 2. Good. As I walk across the x values of 2 and to infinity, my y values are going to decrease. Good. Yeah. Yep. Oh my gosh. The highlighter, we don't need you. Sorry, go away. There we go. So as my x's go negative and my x's go positive, so left side, right side, what are my ends doing? They're going down. So how do I say down? Good. We're going down, down. Oh, yeah. So what's our domain? All real numbers. Or you can say negative to positive infinity. Either way. My ranges.
Less than 2 equal to 4.
Very good. Yep. This time because we're going down, down. Our y's are going lower. Our y's are going down. From that maximum value of the 4. Remember, this is 2, 4. This is the max value of my y's. All right. Do we feel better? Okay. Okay, good. You have a note card if you chose to get one from me. If you want another one, I got more. Or if you want one, didn't get one already. Tomorrow is a quiz. You can use your note card, whatever you put on it.